Okay, so let's look at 1h number 3. We want to show that f of g of x equals x. And remember, this thing means this. So in this case, it's going to be f of 2x plus 3 over x minus 1. Okay, well that thing is the same thing as saying we plug in this for that x and this x. Okay, so that's going to be, it's going to be fractions and fractions here. So 2x plus 3 over x minus 1 plus 3. So this is the x plus 3, except x is really this thing now. Over, and then x minus 2, but x is really this again. Now, what a lot of students want to do is get the 3 over x minus 1 and the 2 over x minus 1 and then multiply it all out. Distribute and add together the two fractions on the top and the two fractions on the bottom. I prefer to use this trick where I just multiply everything by x minus 1 over x minus 1. So I'm just multiplying by 1, right, because this is just 1, so it doesn't change the value. But what I can do then is I'll distribute this to this one and to that one. And then I don't have to deal with the fractions anymore because they'll cancel in the first term. So the first term is going to turn into just 2x plus 3. And then the second term will turn into 3 parentheses x minus 1. And then on the bottom, same sort of thing will happen. I get 2x plus 3 minus 2 parentheses x minus 1. So I think this is a little easier to deal with. So if I work out the top and distribute over the bottom, then I can simplify. So I get 5x on top, and I get 5 on the bottom, so that equals x. Okay. By the way, domain here, the domain restriction comes out of this, x can't be 1. Okay. So, and then there are no new domain restrictions that come out of this because I'm just left with a 5 down there anyway, and if you look at any of the steps along the way, the only issue here is when x equals 1. It turns out also that g of f of x also equals x. So if g of f of x equals x, and we know from part A that f of g of x equals x, this is actually a way to prove that f and g are inverses of each other. Okay. If you wanted to prove it, you know, you could, not necessarily this fact, but prove that these are inverses of each other. Well, let's take, you know, f of x equals x plus 3 over x minus 2, and then actually find its inverse. So this is the same thing as saying y equals x plus 3 over x minus 2. And then what I'll do is I'll switch the x's and y's to get the inverse. So x equals y plus 3 over y minus 2. And then I'm going to solve for y. So x times y minus 2 equals y plus 3. xy minus 2x equals y plus 3. I'll bring the y over and bring the 2x over, and then factor out the y, and then divide. And so these will cancel. I'm left with this right there. Okay.